Hello everyone, welcome to our first lecture. So this is an introduction to data analytics. In this presentation, we will cover the basic definitions of data analytics, what are the data analytics types, and some examples. So first of all, data analytics is the science that analyzes raw data to make informed decisions. So the first step is that we need a data requirement. So in general, there will be like a business problem that we want to solve. So in order to provide a good solution, we need data. So that's where our data collection process begins. And then once you have the data, you need to clean the data. In some cases, you will need even to do some imputations when we have missing data. So once we're able to clean the data, so we start our data analysis. Data analysis involves extracting insights from the data to create value and to do the data interpretation. So here we can also provide even some models, predictive models, that we're going to discuss later. So there are different frameworks to talk about the types of data analytics. So this is just one, and in the next slide I will show you another framework for data analysis types. In even some authors, they mix them up. So in the first one, the types of data analytics, we have the most basic one, which is the descriptive analytics. So pretty much the idea here is to look at the data and try to understand what happened in the past. So the second type of analytic studies is the diagnostic. So here is to understand why did it happen, the reasons. And of course, when you want to predict the future, that's when we start talking about predictive analytics. I would say that most of you are studying data science because you want to create predictive models. So there are different predictive models. You can have regressions, you can have classification models, which I'm going to discuss later in this presentation. And of course, after the predictive models, the last data analytics type that we have is the prescriptive. So it's not just about predicting the future, it's also like how can we make it happen. It's like understanding the variables and ensure that we will get the best possible configuration of variables to ensure that we maximize profit, if that's what you want to do, depending on the business problem that you're trying to tackle. I prefer this analysis or this description of data analysis studies. So, but they are somehow related to the previous one. So here we have in the first study type, this is the most basic one, descriptive. Then we have the exploratory data analysis, the EDA. Let me tell you something. I mentioned before that most of you want to do predictive analytics, but most of the times and most of the companies, like I would say like at least 95% of the time, you will be doing descriptive and EDA because it's required, it's needed in order to answer some of the business problems. The third type of study is the inferential analysis. Then we have the predictive, and then we have the causal analysis and mechanistic. So I will go over each of these data analysis studies. So the first one, which again is the most basic, it refers to summarizing data. So you're doing descriptive analysis when you are computing metrics such as the mean, the median, mode, standard deviation, when you're counting. For example, if you're doing like a census, so the typical information that you get from the census is like the number of people per gender, for example, per group age. So that's just like counting discrete variables. So if you're just like computing some metrics, so that's what we call descriptive analysis. There are other examples. If you want to analyze sales reports only with metrics, like the total amount of money or some percentages, so that's descriptive analysis. Now in your case, as you're preparing as experts in data analysis, my advice is like your most basic data analysis should not be the descriptive one. You should get started with the EDA, with the exploratory data analysis. That should be your baseline. So what is the EDA? So the EDA goes beyond the descriptive analysis, so it's not just computing metrics. Here you want to visualize. Here you want to evaluate the evolution of a variable. You want to see if it's increasing, decreasing, if there are some seasonalities, what's the behavior, the patterns behind all that information. So the EDA is where you understand your data. So it's not just metrics, it's way more than that. Here is where you are gonna generate your hypothesis. So you have that exploration, you have visualizations, that's like a common tool during your EDA. And at the end, you need some hypotheses based on the conclusion that you can get from the data. So again, this always should be your baseline when you're doing that analysis. You should start with an EDA and not with a descriptive analysis. So examples here. So if we're talking about the same sales data that in the previous slide, but now if you want to do an EDA, here you need to check like a time series. So how's the evolution of the sales per month or per week? Maybe here you want to analyze the sales per region to see like how good they're doing, or you want to check some specific products to evaluate whether they're struggling with some product lines. If you want to, a similar thing can be with customer segmentation. You can kind of like understand like which are your most important customers, like type A, type B, or type C. Maybe type A customers are those customers that buy products from you like with high frequency, high volume, while C customers, they buy low volumes of products with lower frequencies. If you're talking about the stock market as a separate example, here of course you will have multiple time series, and you want to see how the evolution of the variable, maybe the price of a stock, if it's increasing, decreasing, or if it's stable, or if it has a lot of volatility. So it's important to visualize it, maybe compute some metrics, but at the end, if you're doing an EDA, you will get some insights and conclusions about the data. So remember, what increasing the difficulty level, descriptive is the most basic, then we have EDA, and the third analysis type is the inferential analysis. In this one, we don't have prediction, but we have estimation. So the whole purpose of the inferential analysis is to draw a conclusion from a sample. So you collect a sample of observations, and using that sample of observations, you want to generalize the conclusions about the whole population. So for example, if you're doing a market research, you can conduct a survey, let's say taking 1,000 customers, that's your sample size in this case, and equal to 1,000. So the idea is to evaluate or estimate the customer satisfaction. So you are going to perform an inferential analysis if, based on the 1,000 customers, you try to generalize the customer satisfaction of the whole population of your customers. Of course, you need to ensure that this sample, these 1,000 customers, they are representative of the population of your customers. You know, like it's not like a convenient sample. You need to ensure that it's stratified, and you are selecting the customers like randomly to make sure that your conclusions or your inference is correct. I would say that the most popular example of inferential analysis is during elections, election polling. Now that we're in the midst of the election here in the US, presidential election 2024, so you will see like every single week, or almost daily, there will be like new polls about how their candidates are doing. So that's an inferential analysis. It's not a prediction, it's just an estimation of the percentage of voters that are going to prefer one candidate or the other. Okay, so now let's talk about the fourth type of data analysis. This is the predictive one. This is the most interesting one. It's sexy, I would say, because you will see in the news, a lot of information about predictive models, predictive algorithms out there, because that's kind of like something interesting for companies and even for the public the general public. So the whole idea here is to use historical data in order to predict what will be the future value of a variable. So here we have like different predictive models, but let me talk about three specific problems: regression models, classification models, and let me talk about time series. All right, so when do you have a regression model? If the variable that you want to predict is numerical, the y variable that you want to predict is numerical, and you want to predict that variable using some independent variables. So let me call them x1, x2, up to xk. So that's a regression problem. Let me give you an example. Let's say that you want to predict the price of a house. That's your y variable, the house price, like the amount of money per square meter or per any other metric that you want to find. So, and your independent variables in that case will be like the size of the house, that's x1, x2 might be located, might be related to location, x3 might be whether the house is used or new. So you can get, like different variables that might affect the price of the house. So that's the problem. It's a regression problem. You want to predict a numerical variable using some numerical or even categorical variables. Now, in order to solve that problem, there are multiple algorithms. You can find linear regression. That's just an algorithm to solve that problem. But it's not the only one. Maybe it's the most popular, but it's not the only one. You can find also regression trees, random forest, XGBoost, neural network. There are multiple algorithms to solve that problem. Now, that's regression problems. Let's talk about classification. In the classification problem, there is also a y variable that you want to predict, but the difference here is that the y variable is not numerical, it's categorical. And then you have some independent variables that you are going to use to make the predictions. Now, what's the difference here? Of course, the output or the dependent variable, that's the main difference between regression and classification. So let me give you some examples about categorical values and classification problems. So some common examples are, for example, for fraud detection in online banking. So financial institutions, banks in general, they want to identify whether a transaction is fraud or if it's a normal transaction. So of course they will use different independent variables such as the amount of the transaction, the country of the origin, maybe the time of the day. So with some of those variables, they will be able to predict whether the transaction is fraud or not. So please notice that here the prediction is not a numerical value. It's just whether it's fraud or if it's an okay transaction. So we have two possible values. This is a binary classification. It can be multi-class classification, but my example is just a binary classification. So F for fraud and N for normal transaction, or it can be 1 or 0 if you want to code it. But again, it's not numerical, it's categorical. In medicine, you will find classification models to predict whether a person has a specific disease or not. So using like different blood tests and different analysis, you can predict the y variable whether the person is sick or not. So that's the difference between between regression and classification. The output in regression models, the output is numerical, and in classification problems, the output is categorical. Now, similarly to the regression, in the classification world, you have multiple algorithms. So here you will have logistic regression, which is quite popular, and there is also the classification tree, random forest for classification, XGBoost, SVM, and there are multiple algorithms in order to solve classification problems. So I have mentioned two predictive problems, the regression and classification. But I mentioned before that, that I'm going to talk about three. So the third one is time series, which is quite popular for companies when they want to predict the sales, like kind of like when they are planning the demand, like how the amount of products that are going to sell for each specific category. So they use time series because they analyze the historical data, like the sales in previous weeks, previous months for one specific product, so they can see the pattern, whether it's increasing, decreasing, if there are seasonalities or not. So they can use some algorithms to solve and to make the predictions. So typically you will see exponential smoothing, also regressions can be used for time series. And of course, there are some adaptations of random forest, XGBoost for time series. Even neural networks, there are some algorithms that are specifically designed to be able to predict a time series. In time series, the difference with regression and classification is that the order matters. Like the variables, they have an order because they have a timestamp. So you cannot like rearrange the data because then you will have problems. In the case of regression and classification, the order of the observations is not relevant, but in time series, it is relevant. It is relevant. Okay, let's continue with the fifth data analysis type. So just remember the first one was the descriptive, the second one, exploratory data analysis, the third one, the inferential, the fourth is the predictive, and the fifth one now is the causal analysis. So we're increasing the complexity. Descriptive is the most basic data analysis type, and the causal analysis it's more complex than the first four data analysis types. What is important here is that it's not that this one is better than the others. It depends on the analysis that you require. So what you need to understand first is which is the problem, which is the questions that you want to answer, so you can pick the right data analysis tool. All right, so let's talk about the causal analysis. So this one is created to establish cause and effect. So you want to ensure that you are finding which variables x1, x2, x3 or xk have an impact in a response variable, but it's not correlation. Here you wanna have full certainty that these variables are affecting directly the response variable. So in the predictive study, the previous one, you can create a regression model or classification model with correlation and not necessarily with causality. So you're very careful because if you're using those tools, you cannot make conclusions like, okay, if you increase x1 or x2 in this amount, or if you decrease it, then y is gonna be affected in this way. So you gotta be cautious when you're analyzing your regression or classification models. Okay, so the gold standard here in causal analysis is design of experiments. So if you wanna find if there is a cause and effect relationship between two variables, so for sure design of experiments is the way to go. So it's important to make the distinction between causality and correlation. So causality implies that one event is the result of the occurrence of another event. So X affects Y, or X is the cause of this variable, while in correlation, it indicates that there is a relationship or association between two variables, but it does not imply causation. So in causality you have correlation, but in correlation you don't have causality. In addition, you gotta be careful because you might make mistakes. For example, if there are confounding variables. So in the confounding variables, it's a variable that might influence both the independent variable and the dependent variable. And potentially, it will lead to the assumption of causality, and that will be a mistake. So let me show you an example. So for example here, imagine that we're in summer, there is a hot weather. So during that time, it's possible that the sales of ice cream or cold products, cold drinks, is going to increase, right? At the same time, let's say that sunburn or even the sales of products related to the beach are going to increase too. So someone might find that there is a correlation between ice cream sales and sunburn occurrences, but there is no causality. I mean, you cannot affirm that because you're selling more ice cream, then people it's getting like more sunburn. That doesn't make sense at all. Because here the variable that is creating this situation, the causation, it's the weather, right? So you gotta be careful when you are doing this type of analysis. You gotta ensure you gotta have a clear distinction between correlation and causation. Here's a link here for a video. It's a 1-minute video that shows you correlation, and someone it's thinking that it's causing an event, but of course it's correlation. So please make sure that you watch the video. It's just 1 minute. Okay, so that was about the data analysis types. Now I want to discuss a little bit more some key concepts. So the first one is data collection. I already mentioned this at the beginning of the video, but I want to expand it a little bit more. So data collection, it's the process in where we gather or measure our data, right? And so here we collect our X variables, our response variables in case we want to predict something. So there are multiple ways in which we can perform this data collection. So of course you can create surveys, questionnaires to ask people, like the population of interest about the variables that you want to analyze, right? We can also use sensor data. Imagine agriculture, if we're measuring the weather, if we're measuring humidity and other conditions. So we might use some sensors to capture this information. If we're analyzing like human patterns, like the way people walk or move in one area, we can use some wearables. We can use some even the video from cameras to analyze these patterns. Transactional data, that's common in companies. So sales, all information regarding the movement of products, shippings, all that information, those transactions are useful when you're doing data analysis. Web scraping, it's also a popular tool. Sometimes you want to get data from different websites, from different sources. So there are some tools in Python and R to perform the web scraping. Just to give an idea, there is a library called Beautiful Soup in Python, and if you are using R-based, those are like some introductory libraries that you can use to perform web scraping. APIs, sometimes you want to use information from Twitter or X, so there is an API that allows you to connect with this social network, so you can kind of like extract some tweets if you want to analyze, like you want to check what people is saying about a specific topic. That's possible if you get the authorization of the API. Same thing with financial markets, weather databases. So a lot of websites, they allow you to do that exchange of information. All right, so a second key concept is data cleaning. The idea here is the process of detecting and removing or correcting our inaccuracies in the dataset. So there are multiple things that we need to consider. So first, how to handle missing values. Typically during the classes or online courses, you will find perfect data sets, right? Especially at the beginning, even in our course, we will use perfect data sets, like everything is complete, we don't have missing data. But in real life, it's possible to have missing data. So there are some different methods to kind of like replace those values to be able to make imputations. So for example, in some cases you can use the mean value for that variable, or there are some predictive models to find those X variables that are missing in our dataset. We need to check that there are no duplicates in our observations, so it's important to identify them and remove them if it's required, because that's going to affect our results. Sometimes you will need to standardize data, so you need to ensure that everything has like similar formats, units, scales. So there are multiple ways to approach this standardization process. Outlier detection is critical because if you have abnormalities in your data, that may affect your results if you're trying to create a model. So it's important to identify and understand those outliers to check whether that's because there were some kind of like an error during the measurement, or if just like an unusual behavior in your data. So the idea here is to check those values, and if you need to, it is important to remove them, or at least you gotta be aware that you have them in your data. Visualization it's important in that analysis. Regardless, you want to do a predictive model, remember you always need an EDA. You want to know your data, you want to get some insights before you move forward with a predictive model. So visualization is critical to understand what you have to get some insights from the data. There are multiple plots, and of course it depends of the conclusion that you want to find, but some of them are heat maps. You can use some bar charts, line graphs, pie charts. We can use histograms for sure to analyze the shape of our data. There are, and these are really popular, dashboards. People are using dashboard all the time, using in Power BI, even in Excel you can create some basic dashboards. Of course in Python and R you can create those dashboards and deploy them in any cloud computing services. So the idea of the dashboard is just to kind of like summarize critical information, critical metrics, so companies can keep track of those variables. If you have geospatial maps, sometimes maps are useful to show location. And what really matters here is not about creating, like fancy dashboards and cool plots. I mean, that's important, of course. But what truly matters is like we're able to connect these plots, these graphs, with the story. So we gotta understand which is the business problem, what is the, as I said before, what are the questions that we want to answer, and try to answer those questions in a compelling way. So this is like how data storytelling looks. So initially we do the data collection, so it can be a little bit messy. So we prepare our data, so we organize the data, right? So here we have the cleaning part, the standardization part, all right? Then in the third step, we begin with our data visualization. So sometimes this is just basic plots. You don't need fancy plots at this stage. The idea is just to understand the data, to see if there are some patterns, and then once you find them, once you pick which are the key plots, then you will try to use a better plot for that. Like to want to improve, maybe we want to use like an interactive library, so the plot it's gonna react when the user clicks in one part and things like that. So then we do that analysis, and at the end, this is what truly matters: how we tell the story. So this is the way you present the analysis. So at the end, this is what people will get. So this is nice, the first part. But sometimes we kind of like fell in love with our code and we enjoy the coding part, which is fine. But if you don't sell the story, then people is not going to use your insights, people is not going to use your model, people is not going to use what you found. So it really matters that you communicate this in the best possible way. So people is going to buy the idea, and the company is going to implement what you are suggesting. All right, in regard to the tools, so these are important tools, Excel and SQL, even though we're not going to teach them in this course. I have to say that Excel, it's popular. I mean, in small company, medium company, every company, you will find people using Excel, especially for descriptive analytics and also for the EDA part. So it's a popular software because it's easy to use in general. So most people they have a basic idea on how to use Excel. It has some limitations, of course. So if you want to like create predictive model, it's not good for that. If you have high volume of data, that is not good. Then it's limited. It's limited the capacities, especially when you're trying to move forward in the data analysis types. If you're trying to do something predictive or more, it's not recommended. SQL, you really need to learn SQL. So even though it's not in our syllabus, I mentioned before that in the previous video, I believe that maybe I will spend one lecture talking about SQL, or I will provide some extra material in case you haven't used it before, because I'm pretty sure that at some point in your professional life, when you're doing an EDA, an exploratory data analysis, and when you want to answer some business problems, you need SQL. You will need to some queries, like to get some specific information. So this is what our course is about. You will learn R and Python. So both are wonderful for data analysis. Maybe I'm gonna point the strengths, at least in my opinion, from one and the other. So in the case of R, let's say that R was created mainly for statistics and data science. So what is interesting is like you will find some specific libraries and packages that where you will be able to implement some like state-of-the-art methods, right? Because researchers are using R, maybe in statistics, in machine learning. So you will find like very specific methods that maybe are not in other languages. Now, one of the limitations maybe is the power. I would say that when you are working with videos, images, and you need like neural networks, typically people won't use R for that. You will see like the most popular libraries for neural networks, especially with data that requires like a lot of storage, a lot of processing power. People will prefer Python in that case. So you will see TensorFlow, Keras, that are like the most popular libraries in terms of neural networks. Now, Python, it's a programming language, so it's quite popular, it's multi-purpose. So if you ask me, you should learn both, but if you need to pick one, thinking in your professional life, I would say Python. I mean, I like both, but I think Python will open you more doors than R. Again, you should learn both, and in this course you will learn both. But if you need to master one like really good, my advice is that you should go with Python. Okay, so the whole purpose of this presentation was to first understand different data analytics types and the different data analysis tools. It's important to know that, and I mentioned this before, that even though I showed them as separate frameworks, at the end they can like be together. The 5 data analysis tools and the 4 data analytics types. So they are relevant because once you identify the type of study that you need, then you have full certainty on how to proceed. The second key aspect of this presentation was to show you like the relevant software for data analytics. So we talk about Excel, which is basic, SQL, which is required, is a must for all of you. Python and R is the focus of our course, and it will take you from descriptive analytics all the way to causal analysis. And finally, you should know that data analytics is critical. It's a key driver for strategic decision making. We need the tools to be able to manipulate data, to process our data. Remember that what I mentioned, that I would say that at least 90% of the data analysis that you will do in your professional life are EDAs, at least, because you always need an EDA. And sometimes the answer is just an EDA. It's not a predictive model or pattern identification. So you need to learn the libraries to do that. In the case of R, you should learn the tidyverse. In the case of Python, we will use pandas, which is the standard for this part. Okay, so having said that, I'm gonna conclude the video. I'll see you in our next lecture.